So today we're going to be doing an integration by parts problem, and this one is actually from our math practice on day 24, but we've been asked to do we've been asked to find the integral of x times cosine of x, and we were given these requirements, I guess, but to try to do these. But before we get to that, the formula we're going to be using is this one right here, where it says if you have the integral of f times g prime, it's going to equal f times g minus the integral of f prime times g. And so we're reminded that when we're trying to, because what we want to do is we want to assign one of these variables to either f or g, and so we're reminded that when we're picking which one is which, that f prime should be something you know the antiderivative of, and g of x should be something that gets simpler through derivatives. But another way I like to think about it is that f prime should be simpler than fx, and that g prime is something that you don't want to become any more complicated when you find the antiderivative of it. And so what it means by either simpler or more complicated is, for example, if you end up integrating it and it adds on like another degree higher, or if it adds on more terms, etc., it's a little harder to work with, so that that could be a little bit more complicated. And so these two are basically kind of saying the same things, but these are kind of general, I guess, general guidelines that you would want to follow when choosing which one of your variables should be x or f or g. Because we are given, because f and g are kind of given to us for our two tries, we're not going to be using these guidelines right away, but you'll see how we kind of will use them a little bit later on. And so let's start with this first one here. And so anytime I like to do any derivatives or finding the derivatives or antiderivatives, I like to make sure I write them down first and then kind of do a plug and chug later. So for this first one, for example, we know, or we're told, that our f prime of x is going to be equal to x. And so that means our integral of f of x is going to be x squared over 2. And so this is kind of by following the polynomial rule backwards, which is a little quick reminder. If you have, for example, x, and this is taking the derivative, if you have our x, then what you're going to do is you're going to multiply the coefficient by the exponent, and then subtract 1 from the exponent, and then that will be your derivative. And then, so if you were to take, or for example, to take the integral of that, you would have x to the power of something, so you would add 1, and then divide your coefficient. So this really shouldn't be under x, but you would divide your coefficient by the value of that exponent. So a really quick example is if you had, here, let me put this over here, put them side by side. So if you had 3x to the power of 3, to get the derivative of this, you would first, you would multiply your coefficient by the value of the exponent, and then subtract 1, and then you would be done. So then if you do 3 times 3, you get 9, and then you would subtract 1 from 3, so then you get 2. So your derivative would be 9x squared. And so to get like the integral, so if you have 9x squared, you take the value of your of your exponent, you add 1, and then you divide your coefficient by the new value. So here you have 9x squared. You would do 2 plus 1, which is equal to 3, and then divide your coefficient by that new value. And so 9 divided by 3 is 3. And so this would be your integral. So f, now that we've kind of reminded ourselves of the polynomial rule, here we can act as if, this x is to the power of 1. And so if we're trying to integrate it, we're going to add 1, so 1 plus 1 is 2. And then we're dividing the coefficient, which would in this case be 1 over 2. And so like x multiplied by 1/2 would be the same as saying x squared over 2. So that's how we got that one. And so for our other one, here it's saying that it would like us to make g of x equal to cosine of x. And so if g of x is equal to cosine of x, that means g prime, or the derivative, will be equal to negative sine of x. And this is just something we've learned throughout our lessons. Okay, so now that so these are the ones that were given to us. So now that we know what our little variables are, I guess, we can kind of plug them into this general formula thing we've got. So if we want to rewrite this just to make, so we have f x times g prime x dx equals f of x times g of x minus the integral of f prime of x times g of x dx. Okay, so now you can just kind of plug and chug, and you can put in, and we said f of x was equal to x squared over 2. And then g of x is equal to cosine of x. Okay, minus the integral of f prime of x, which we said was x, and g of x, which we said was cosine of x. Okay. So now what you'll notice is we have another integral here. And it's not something we can easily find the integral of, because there are two functions being multiplied together. If it were something simpler like, just cosine of x, then we could easily just find the integral of that because it's just 1. But these are two functions. So what we have to do is we have to do an integration by parts again in order to find this integral, and so we can find our original integral, or to solve for like the original problem. So this is where we can use our little guidelines. And so if we take a look at what we've got, we have x and cosine of x. So we kind of want to think about which one would end up having a simpler derivative or a simpler antiderivative, I guess. So if we look at x, let me grab, I guess, another just a quick sticky note right here. So if we look at x, the derivative of x is equal to 1. And again, that's kind of like following the backwards way of the polynomial rule, because like x to the power of 1, or x could be thought of as to the power of 1. So if you bring down 1, and then make x to the power of 0, that's like saying 1 times 1, so that's equal to 1. So this is the derivative of x, but the integral of x, which we actually found from before, is x squared over 2. So we can see right off the bat that this one is a lot more simpler than this one, because this one kind of became like a fraction and like the power went up 1. So, but we can also take a look at the cosine. And so the derivative of cosine, we said, since we found it here, right here, derivative of cosine in terms of x is equal to negative sine of x. But from previous lessons, we do know that the integral of cosine, the integral of cosine is equal to sine of x. And if you notice, negative sine of x and sine of x aren't necessarily any more complicated or simpler than cosine of x. So if we look at our guidelines, we know that we would probably want f of x to be equal to x, because when you find the derivative of f of x, then it ends up being, or f prime ends up being a lot simpler. And so if we made f of x equal to x, the derivative would be 1. And here, we would probably want g prime to be cosine, because if you were to integrate it, it doesn't necessarily become any more complicated. And then here's this other guideline that when you get the derivative of g of x, so if you were to take cosine and then the derivative, it doesn't necessarily get that much simpler either. So I want to say it kind of like stays within like the same range of hardness. But anyway, so for this one, when we're doing the integral of this one, we're going to assign x to f of x and cosine to g of x. And remember, since we're doing in order to solve this, we have to redo the integration by parts. So we have to follow this whole entire thing now, except with in terms of our new f of x and g of x kind of thing. So we said to solve for this integral, that our f of x is going to be equal to x, which means the derivative of that is going to be equal to 1. And then for our g of x, it's going to be equal to sine of x, and that the derivative of that then is going to be equal to cosine of x. And this is just kind of my thinking, but I think the reason why we specifically are kind of like looking at f of x and the g prime of x and not, maybe f of x and g of x, or let me reword that. The reason why we're assigning our variables to f of x and g prime of x and not f of x and g of x is probably because if you look at our original formula, it's saying that f of x times g prime of x. And so those are obviously the ones that we're going to want to assign our variables to. So because we don't have like a g of x, we're not going to want to assign cosine to that because it's not asking for that. It's asking for a g prime of x. But anyway, so now that we know what these ones are for this integral right here, let's quick do integration by parts for this one so we can solve our original problem. So again, we're going to do f of x times g of x, which we said was x times sine of x, right here, then minus the integral of f prime times g of x. So 1 times sine of x. Now here, we are able to just multiply these together because one of them is just 1. And so that doesn't really change the functions around, so we can kind of ignore this one. And then we'll see that now, let me rewrite this. It's just asking for the integral of sine of x. Okay? And so when you're integrating sine of x, that turns out to be negative cosine of x. So what you get is x sine x minus negative cosine of x. And then if you have a minus and then a negative, then you know that kind of becomes like a positive, like you have this plus this, because the two negatives kind of cancel out. So then what you're left with ultimately is x sine of x plus cosine of x. Okay, and all of this goes to here. Okay, so now that we know what this integral is, we can plug this back into here and then solve for our original equation. So our original problem, so x squared over 2 times cosine of x minus x sine of x plus cosine of x. Okay, and so that's how you solve for x times cosine of x if f prime were equal to x and g of x were equal to cosine of x. Oh, and then because it is integral, you are going to have like a plus c at the end, which just means it's a plus constant, because when you're integrating, you can have tons of different integrals for one equation, I guess, because really the constant just moves the graph up or down. So you can have a bunch of different graphs with all the same derivative, but it doesn't work the other way around. So you can have a bunch of like integrals with just from one, because this constant can change and be moving the graph up or down, if that made any sense. So here's that one. Now let's try the second one right here, where it says instead make f prime equal to cosine of x and g equal to x. So we'll do this in a different color. Okay, so it says our f prime is going to be equal to cosine of x, which means that its integral is going to be equal to sine of x. Okay, and then it also says that now our g of x is going to be equal to x. So g of x equals x, and then we kind of discussed it before, that right here, that the derivative of x is equal to 1. So g prime, in this case, is going to be equal to 1. Okay. So again, let's rewrite our formula, so just for ease. G prime of x equals fx times gx minus the integral of f prime x times gx and dx. Okay. So again, we can kind of just plug and chug real quick. And our f of x, we said, was equal to sine x. G of x is equal to x times x minus the integral of f prime, which is cosine x, times gx, which we said was x. Okay, and notice again that here we have another one, or multiplication, and it's actually the exact same thing as the one we did up here. They're just kind of switched around. So see cosine of x times x. So what we can do is as one of my professors said, work smarter, not harder. We can just take what we got already calculated here and just reuse it up here because it's asking for the same thing. So it ends up being sine x times x minus x sine of x plus cosine of x. And then here you can actually simplify this further because since this is kind of like minus, and then if you have a minus in front of, I don't know what to call it, but like a part of the equation, it's kind of saying like plus negative this and negative this. So we can actually distribute this minus sign or the negative sign to these two. So it would go like to this one, and it would go to just this one as like a whole because it is multiplied. And then it would go to the cosine. So then we can again rewrite it as sine x plus negative x sine x plus, again, negative cosine x. And then, if you notice, here we have, they're a little, this one's a little twisted around, I guess, but it is the same thing as this one because you have an x times sine of x, and this one is a minus, and so since we're adding them, these two can cancel out because it's kind of like, 1 plus negative 1 is equal to 0. So then all you're left is this, negative cosine of x. So for this one, the integral x times cosine of x, when f prime is equal to cosine x and g of x is equal to x, equals negative cosine x plus c, because we're integrating. All right. Now, something I didn't really write down when on this little piece of paper with like the prompt on it is what was asked in our original problem was which way worked and why. I'm not really sure of the answer, the correct answer, I should say, but I would like to point out that if you noticed when we were doing these two methods with those requirements that were given to us, our original problem was to find x times cosine of x. But when solving it these ways, we ended up getting that exact same integral within our integral. So we had to do another integrating by parts, but it was of the same integral we were originally trying to find. And so that's a little odd. I found that a little odd because I'm like, well, that seems kind of redundant and not useful at all, to be honest, because if we were to keep, following those same requirements, we would kind of be getting nowhere because it seemed like we would end up having like this endless loop. But if you notice the way we did it up here, when we didn't follow the requirements that were given to us, and we instead followed the guidelines and made f of x equal to x and g prime of x equal to cosine of x, we found that we ended up getting this. And so, in a way, you could, let me rewrite it. In a way, I would say the absolute most simplest way to solve for this integral, sorry, let me rewrite that. The most simplest way to solve for this is to make f of x equal to x, which means f prime equals 1, and then g of x equals to sine of x, and g prime of x equals cosine of x. And so that ends up giving us, I'm not necessarily going to do all the math since we've seen it already, but that gives us the whole x cosine of x. And so it's kind of interesting, I think, because if you compare all of these, I wonder if I can fit this. Boop, 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 just barely. If you compare all of these, it's odd because this one was the simplest method and got us to, you know, I guess a final integration faster since we didn't have to like reintegrate this a second time. But this one ends up just giving us negative cosine of x, which seems like a lot more of a simpler answer. So I'm not too exactly sure why that is, but I believe that this is the way to go, because if you were to use a computer and check, so grab this right here. For example, if you were to put in here that you would like to find the integral of x times cosine, let's try that again. Integral of x times you'll find that it gives us x sine of x plus cosine of x, which is what we got when we did it this way. And, you know, I would like to think that, you know, the computers take the most efficient way or like the easiest way, but I'm not really exactly sure how this whole thing kind of works out, I guess. But I think it is kind of interesting to see. But anyway, that is how you do this problem. And then just kind of solving it out using what we were given.